This video here for Chem 161, some chapter 1 content here where we'll look at using Sig Figs in calculations. So this is something that we often have to do and have to pay close attention to our Sig Fig rules and understand how to report out into our final answer with the right amount of precision and therefore the right number of Sig Figs. So we have a couple of cases. One where our work involves only multiplication and division. Okay, so let's start there. Where we only work with multiplication and division. Okay, so the rule here is to round the final answer to the least number of Sig Figs in any of the numbers used in our calculations. Okay, so let's look at a couple of examples. If we were simply already given the calculation to do, 144.6 centimeters, maybe this is the edge of a rectangle times the other edge dimension, which could be very small here in this case, 0.0023 centimeters. So we're getting the area. And so this is a simple multiplication. The product here is the area. And so if we punch this out on our calculator, we'll see a number like 0.33258 centimeters squared. And so maybe previously you were allowed to leave the answer like that, but now we know something about precision that's already reflected in the amount of Sig Figs in these two inputs into this calculation, and we need to put that information together into our final answer. So our final answer has to be to the least number of Sig Figs that was used in any of the numbers used in the calculation. So we better count Sig Figs in the first number and in the second number. Well, looks like we got 4 Sig Figs here. Leading zeros don't count, and we got 2 Sig Figs here. So our final answer has to be to the least number, so just 2 Sig Figs. So we're going to answer back with only 0.33 centimeters squared as our final answer. Okay, any additional information after that second 3 is putting too much precision in the answer and is not correct. Okay, as a word example, you might have something like this. Okay, so let's say, what is the average mass of a piece of metal weighing, okay, so we're going to get a couple of numbers here, 35.7 grams, comma, 34.999 grams, and the final number, 34.82 grams. Okay, so here we've got to do some addition and then divide by 3. Okay, so clearly this example needs an additional rule. So let's look at that rule to handle this example here. So to help us out on this, let's look at the next rule, and that's for addition and subtraction. Okay, so for addition and subtraction, we want to work with the number of digits ends up limited in our answer, and in answer is limited by the number in the calculation with the smallest number of decimal points. Decimal points. Okay, so if this was scripted out to us in an example, it would be something as simple as this. Say, for example, 5.42 grams added to 131.1 grams. And this is going to equal some value, so clearly we'll have grams there. So if you punch this out on your calculator, you might get 136.52. And previously this might be where you stop, but now we need to think about precision. In this case, we're doing addition only. So now we got to count the decimal places. This is important, decimal places, not significant figures. So let's look at that. I'll even use a different kind of thing here to help us there. And so number of decimal places this time, we've got 2 decimal places, the 4 and the 2, establishing 2 decimal places there. In this case, we've got 1. We're in the tenths in the 131.1. So this is telling us for addition and subtraction that we report our final answer out to a number that is reflecting the least number of decimal points. So if you have an answer in your mind, you can pause the video and write that down or work it out and resume the video when you're ready. But we need to work with 136.5 grams as our final answer. We report out to that first decimal point position because we were there in that first number. Okay, so with that rule, I think we can tackle this word problem here, where we have 35.7 grams added to 34.999 grams added to 34.82 grams. This would be the sum for the average calculation, and of course we would divide by 3. So let's just do the sum first properly, thinking about the decimal points here. Okay, so the sum is going to be 35.7 plus 34.999 plus 34.82. And our sum here is 105.519 grams. And of course our average is that sum value divided by 3. So I'm going to write it out as is, divided by 3. Now let's talk about this 3 number. This 3 number, we can ask, how precise is it? How many significant figures are here? Well, we've weighed something 3 times. It's exactly 3 times. There is no ambiguity to that. We've done that exercise not twice, not 4 times, exactly 3 times. So this takes us to our sort of side topic here, which is rules for Sig Figs in whole numbers, so in exact numbers. Okay, so let's talk about those briefly. So these have infinite Sig Figs. Okay, so the 3 in this example, the 3 separate measurements we did, has infinity Sig Figs on it. Okay, other examples, maybe you've counted exactly 9 oranges at the supermarket. That 9 has infinite number of Sig Figs. Maybe you know that 100 centimeters is equal to 1 meter. This number and this number in this identity have infinite number of Sig Figs. So if we were to multiply by 100 over 1 to transform meters into centimeters, we would be multiplying by numbers and dividing by numbers that have infinity Sig Figs. Okay. Likewise, maybe you're familiar with miles to feet. So 5280 feet is 1 mile. Again, there's a bit of an identity there. And so these are given infinite number of Sig Figs when we work with them as a conversion factor. So this 3 is an exact number and it has infinite Sig Figs. So in our sum, we knew that we had to report to using the addition rule to the decimal point. And so here we have a number with 1 decimal point. The next one has 3 decimal points. The next one has 2 decimal points. So we need to be thinking about answering off at this 5 position. And when we divide by something with infinite number of Sig Figs, that does not modify that outcome. Okay? So dividing through here to get our final answer, you would get our sum divided by 3 is going to equal momentarily 35.173 grams as the average, but for a final answer going to that first decimal point, 35.2 grams is our final answer there. Okay, so hopefully this has taught us not only how to handle multiplication division only type questions and how to report out with the correct number of Sig Figs in this case, but also to handle addition subtraction problems, which now we simply look carefully at the decimal place positions and report out correctly there. And then in a more advanced problem where we have to combine ideas about addition and division, if you want, and we've touched on exact numbers here. Okay? So sometimes you'll need to do tricks like what we've done, is to think about precision midway through your calculation if you're doing addition first, and then you start to do a multiplication to think about how you combine these rules here. Okay? So hopefully that clarifies a few things.